And we're currently recording. So I'm going to start with chapter 11, question 1 by JT, and move to the next 3 questions in the lab per Carmen's request. And then we're going to do chapter 10 for Alana. So we're going to go backwards, I guess, instead of forwards. I'll probably work through the entire of lab 11 and then quiz 11, and then I'll work backwards to lab 10 and quiz 10. And I think that should be a good 2-hour session. If at any point I'm going too fast or I make the mistake that I traditionally make, which is not switching around windows for you, let me know, okay, guys?
Absolutely.
So, assignment. I love your background lights. I love the northern sky lights, the northern lights. It's beautiful.
Yeah. I was disappointed. I've been deployed up there a total of 4 different times. I spent over a year up there and I've never got to actually see them. All the times I've been there, never got to see them. I missed them by like a week or missed them by a month or left a week early every time.
Oh, wow. Well, the nice thing is you have a long way to go in your life. And so
Yeah.
you can definitely take advantage of some time where you can plan a trip and go see that. My wife has wanted to see Northern Lights forever, and I've been like indifferent about it. I think I'm gonna surprise her with a trip there one day during the right situations and conditions. But
Alaska is by far one of the, I've been to a bunch of countries. I've been all over the place, and Alaska is the most beautiful place I'd ever been.
Well, that's good to know. Good to know.
Yeah.
Okay, so I am opening currently chapter 11. Chapter 11 is about the statistic, the average, the mean. So what we do in chapter 11 is begin to go over inferences for the average or for the mean. And so just like we did in chapter 10 and in chapter 9 for proportions, we're going to do the same in chapter 11 for averages. Okay. So back in chapter 9 and 10, we talked about inference. And we said that inference is when you learn to read beyond what is self-evident in data. So we said inference is when we take data, and then from the data we measure statistics. And from statistics we proceed to make inference. And what inferences are is how do statistics tell us about population characteristics, or what are called population parameters. Okay, so in chapter 9, we started with categorical data. And from categorical data, we measure proportions from a sample. And then in chapter 9, we learned how to build confidence intervals. For population proportions. and to test hypotheses about population proportions. So that was our job in chapters 9 and 10. We'll work on that later. Now what we're going to be doing is we're going to be starting from quantitative data. And one of the statistics we learned to measure from quantitative data were sample means, what we call the average, and sample standard deviations. And that's what we call spread, a statistic that measures spread. And what we're going to learn in chapter 11 is to build confidence intervals, that estimate a population mean, and to test hypotheses about population means. And the key part to going from the statistics to the inference side of things, the key to that is what is the model? What is the statistical model that we're going to be employing? What is the sampling model? There are two. So it's not just one model. It's just not just a normal model, but there are two models for means. Okay. One model is a normal model. And another model is the t-distribution model. So chapter 11 has one new aspect to it. And it's the so-called t-distribution. How does the normal model come about? The normal model comes about when you have a random sample of independent observations where the sample size is not too big and where you know, and this is the most important part, you know the population standard deviation. In a t-distribution model, we're going to have a random sample of independent observations and the sample size is not too big. And you don't know. You do not know population standard deviation, so you have to substitute. So you use the next best thing, which is a sample standard deviation. So in one case, we have a normal model. And other times, we have a different kind of probability model behind the use of confidence intervals and behind the use of hypothesis testing. Okay. So when you have the sample standard deviation, that's when you have a t-distribution. When you have the population standard deviation, that's when you use the normal model. Okay. So that's the most important thing about your chapter 11 inferences. opposed to your chapters 9 and 10 inferences. Okay. So this is a good board to take a snap of, because this is going to be our foundation for chapter 11. Anytime you have the population deviation, you're going to use the normal distribution. So we're going to call that the z-test. And anytime that you don't, anytime you have the sample standard deviation, you're going to use the t-test in your stat crunch. So sometimes you're going to use stat z-stat, sometimes you're going to use stat t-stat. In the computation of stat crunch values. All right, so now let's go into our lab with that background. And so we're going to look at lab 11.
Question one. On your screen, what question one would it be for you?
It's the lab is always going to have maintain the same order. So I'm copying this problem from the lab, which is about people's cholesterol levels. So you have, according to a recent poll, high cholesterol level is something that affects a lot of people in a community. And when people have high cholesterol levels, the community tends to have a lot of medical problems. So we're going to assume that we know the population standard deviation. So the reason for that sentence that I just highlighted is that that sentence indicates that we're going to look at a normal type of model, not at a t statistic. So this is what indicates to us that we're going to be interested in z-stat, not t-stat. That it's going to be a normal distribution in our situation here, because I know the population deviation. So what else do they tell us? Well, the next thing they tell us is that according to a recent study, the average level of cholesterol in people The average is 207 milligrams of cholesterol in a deciliter of blood. And the standard deviation of the population is 35. And again, it's a normal process or a normal model. Okay, so what we learned from that is that one person's cholesterol level follows a normal model, where the mean is 207 and the deviation is 35. And then the average of 42 persons' cholesterol level will also follow a normal model. We'll also have a mean of 207, but the standard deviation is going to be a little different. The standard deviation is going to be 35 divided by the square root of 42. So where is this 42 coming from, and what is it doing for us? What is
Healthy adult count.
It's the sample size here of the adults taken from the region. So the proper model for any probability that is a question regarding the average cholesterol level of the sample means that we're going to use this second model that I'm currently boxing in the yellow box. And so when the question is asked, what is the probability that
Will be no more than 207. In the normal calculator, when you use standard, you'd be using P is less than or equal to.
Right. So you go into the, so to do this calculation here that I'm about to turn into black and white, the Y over bar, an over bar is when you have an average Y. A Y bar, and then when you have the less than or equals to, we're having less than or equals to 207. To do that, the math for that, we're just going to go stat, calculators, normal. That's going to open a normal calculator. We're going to set the mean to 207 in my case. Your question might be different. Your mean could be 210 or 205, whatever it is.
Or 209.
Exactly. And then you set the standard deviation. And this is really important, to the standard deviation of the population divided by the square root of the size of the sample in your model. Okay, so it is the standard deviation of the normal distribution of the average of 42 people. So it's not the standard deviation of one person, but of the average of 42 people. And then you leave the calculator in standard mode, and you set the probability question to a value of 207. And then what you'll get is the answer. In StatCrunch. So let me go to StatCrunch and do that. Okay, so the first thing I'm going to do is go back to the question. Then inside the question, I'm going to go to question help and open StatCrunch. So I'm still waiting for StatCrunch to open. Now I can share StatCrunch. So I hope you see StatCrunch. So I'm going to go stat calculators normal. As you may recall, my mean was 207 in my problem. So put whatever your mean is there. The standard deviation of the population in my case was 35. But I'm not interested in the standard deviation of every person in the population. I'm interested in what happens to the average when I have a sample size of 42. So after putting in the standard deviation of one person, I divide that by the square root of the sample size. And then I put in the cutoff point and compute. And I get a picture that says that the answer is 50%. So if I go back to the question, and I put here 0.5, I get the right answer. For part B, the question becomes, what is the probability that the average of the cholesterol readings is between 202 and 212? Okay, so for part B, part B looks like that. The question is then going to be the probability that between 202 and the 212, you find the average in that valuation. Then I'm going to just use the normal calculator in between mode, like we learned to do in chapter 7. Okay. So I'm going to go back to StatCrunch to get the answer now. I hope you can all see the calculator. And instead of using the calculator in standard mode, I'm going to use it in between mode. And I'm going to start it at 202 and continue it to 212. And so now that's the probability that when I average 42 persons' cholesterol readings, I get to that level, 0.6454, 0.6455. And as you can see, the calculator does the right thing. So then if I'm interested in the next probability that the average is below 197,
We're going back to standard.
back to standard. Nothing else changes. And then except for the limiting point, the cutoff value is now 197 instead of 207. That's that 3.2% that you see in the left tail here is the answer. Because the mean and the deviation are of the same kind for the average of 42 persons' cholesterol level. JT, so you asked about this question. Is this making sense now? How to work through problem one?
Yeah, it makes a lot more sense now. I couldn't figure out the calculator part.
Yeah, the only part that's confusing sometimes or most times in this chapter is that you're no longer talking about one person. You're talking about what happens to the average of a bunch of people. So when you start sampling from a certain population and you're looking at individuals, some people are going to have really low cholesterol. Some people are going to have super high cholesterol, but the majority of people are going to be close to normal. So the average of 42 people makes the spread go down from 35 units to 35 divided by the square root of the sample size, whatever the sample size happens to be. And so that new normal model is obtained as in a more less spread out fashion because of the averaging process. And it happens to be normal because we know the population standard deviation for some reason. In this case, we knew it from earlier studies, what the amount of spread in the cholesterol readings of people in that community. So we knew that 35 represented a population standard deviation, not a sample one. If it had represented a sample deviation, then as opposed to a population, that's when we would have used the calculator called a T distribution or the T model. Notice how the T model doesn't stop at 68, 95, 99.7 percentage within 3 deviations. The T distribution is more spread out because it accounts for a greater amount of error. And so in chapter 11, when we talk about means, there's the possibility that we could see more standard deviations from the mean than in a normal situation. In a normal situation, we always see 68, 95, or 99.7%. Okay, so what's really happening here is if I were to put these scales in parallel to each other.
Alan, it's showing the question from the assignment still on the screen.
Yeah, thank you. So when I show the T distribution compared to the normal, notice how the T distribution is more scattered. You can see more deviations from the mean in a T world. Okay. than in a normal world. Okay. So notice how 68% in a t distribution goes farther, goes 1.005 deviations each way. In a normal world, 68% of the model is almost 1 deviation. So this curve is got a lot more room for error, farther from 3 deviations from the mean. Okay. The T model allows you to capture error more standard deviations below and above than the normal model. And so that's why we use it. We use it in situations like the average, like the statistic sample mean, because a sample mean is subject to greater error if we don't know the population standard deviation than if we do know the population standard deviation. So that's the difference between using a model T and a model Z, a model normal versus a model T. Okay. Should I complete question 1, or would you like me to move to question 2?
I got the rest of it. Unless someone else needs you to complete it, I'm good. Thank you.
Oh, I'll leave some excitement for you guys. I don't want to rob you of everything.
Yeah, after you explained it, after you did the first one, I was able to finish the rest of it.
Everything made sense. Back
Yeah.
to chapter 7. So you're back to chapter 7 after that point. So okay. So in this second problem, you have a random sample. The sample is of size 18. The average of the 18 purchases that people made at some convenience store was $50 per person on average. And the standard deviation was $21.05. So it would be common to see somebody spending $71, $72 or $30 or $29 because that's within 1 deviation of the mean. Okay, so the first question is, what is the standard error of the average? And the standard error of the average is the ratio of the standard deviation divided by the square root of the sample size. So again, we're going to use the standard deviation for 1 person. And this time we're dividing it by the square root of 18. And that's what we call the standard error. The easiest way to calculate the standard error is to open the data in StatCrunch. And then to ask StatCrunch in its summary statistics column, like we did in chapter 3, and just ask for the standard error of the variable 1. So the standard error goes after the standard deviation is computed, and you'll see that it's 4.96. So that's how easy it is to calculate, to do the arithmetic in this question. So the answer here is 4.96. And I found it by going stat, summary stats, columns, and you select var1, and you select the statistic standard error. And you click on compute. And you get the 4.96. So that's how you would compute us. If the only question is basically what is the standard deviation for this statistical average of 18 purchases, of the random sample of 18 purchases, you just take the standard deviation of the purchases and you divide it by the sample size, square root it. And that's how we get that. I hope you took a picture of this. And I'm currently just gonna then delete everything back. The next question is, what happens to the standard error if the sample size was 2 instead of 18? And the answer is that when you have less data behind a statistic, you have more error. So because your data set is going from 18 to 2, you have less data. Less data is less information. When your statistics are made from less information, you're going to have more error. So
Data is information.
Pardon?
Data is information.
With a
Just
context.
like you told us at the beginning.
Data is information with a context, correct. And so if you have less of it, your statistics are going to be more poor. Your statistics will be less accurate, will have more error. And so in this case, the amount of error is the amount of data is 9 times less data. So you're going to have 3 times more error. The new standard error is going to be 3 times bigger than the old. So where do I get this 3 times bigger than the old? Well, the formula for standard error is the ratio of the standard deviation divided by the square root of the sample size. So if the sample size is smaller by a factor of 9, then the error is larger by a factor of the square root of 9, which is 3. Does that make sense? Because of the square root of n here. You have 9 times less data because your data set is only 2 instead of 18. So you have 9 times less data. So you have 3 times more error. And that's called the inverse square rule. You have less data, your error will be bigger by a factor of the square root of n. If you have more data, your error will be smaller by a factor of the square root of n also.
I have a question.
Yes, Carmen.
Spanish.
Oh, please.
Yes, fine. So I did the same thing. So my question is 5 instead of 20. And I just did the same formula. And I just put root 5 instead of 20.
So your first data set was 20?
Yeah, it was 20.
And
But
now
then-
it went to 5, right?
Yes.
Okay, so from 20 to 5, it went down by a factor of 4. And
Four.
the
I
square-
actually, I got that
Okay,
too.
got it.
and the square
And I
root of
see-
4 is 2. And so your answer should have been 2 times the old,
2 times.
right? Because your data set went from 20 to 5. That means that
Yeah.
it's 4 times less data. And the square root of 4 is 2, so you have 2 times more error.
Oh, got it. Yeah, that was my bad.
No,
I did the same formula. That's why I got the wrong answer.
Ah, yeah, got it. So yeah, so you have to figure out by
Thanks.
how much more data or how little data you have. And then I think Alana, you had another a part to
No, it's good. I realized that I had submitted 4 and I didn't take, and then I didn't do the 2. Okay.
Oh, the square rooting of the 4? Yeah.
Yeah, I did not square root it. Thank you.
Yeah, cool. No, that's nice. That's good. So yeah, that's why it's called the inverse square root.
I use mostly question help to figure that out. That came with that question itself.
Right. But now you know that there's this that because of the shape of because of the way the formula for the standard error of the average goes, where you're dividing by the square root of the sample size, if your sample size is scaled down, you're going to have a bigger error. And if the sample size is scaling up, you're going to have a smaller error. So that's the inverse part. And then the second part to the math is to do the square rooting of that factor so that you can.
Alan, I had a quick question.
Yeah.
On the part B, when you had all of the like stat summary and stuff like that typed out, is that on any of your notes anywhere? Like the actual like steps?
Well, chapter 11 is the lecture for this coming week, and it's in my notes for chapter 11 notes. Let me go look for them.
As I say, you don't have to do it right now.
No, it's healthy to do it right now. It's a good
Okay.
thing for me to break. So you go to course tools.
Okay.
You go to course tools, then you go to document sharing. And under exam 4 module,
Okay.
there should be exam 4 notes on chapter 11. And that's up near the top here.
Okay, and there's also one that says exam 3 notes for chapter 10 and 11, but it says underneath it says exam 4, not 3.
Right. So you could also look at that one.
Okay.
And then when it downloads like I'm downloading here, you will see that inverse square rule being played out in the notes there. And those are the notes that I'm going to base my last 2 lectures on next week, the Monday, Wednesday, Tuesday, Thursday lectures. So
Okay.
I'm going to do a little bit of play on chapter 10 and then do chapter 11, and that'll be our semester.
Do you know when we'll know what we got for the extra credit?
I'll try to have that done by end of week, but because I'm still receiving them, so I'm still accepting them, and I did say May 15th just so that I could go over them and give you guys your points and whatnot, your partial credit, and do careful grading. So I think you'll be able to see it on Canvas towards the end of next week, and and add close to your 200 points of extra credit there to the labs and the quizzes that you completed and to the exam grades that you've completed.
So it's not too late to submit?
No,
Or-
but turn it in.
I want to be able to do it, but Canvas is not letting me access it.
The extra credit should be in the announcements of your section.
Yeah, I'm there. It's every time I try to click a link, it's never
Don't
going to
click
let
the
me.
link. Just go to the file on the bottom. Just go to the file that says extra credit chapter 8.doc.
It keeps saying the same thing. Access denied.
We actually had that trouble about a couple weeks ago or a week ago, and he uploaded it to the files, and if you go into the file, it should let you access it.
So Sam,
Miles?
do you see where I am right now, Sam?
Announcements, yes.
Okay, you're in section 2330, right?
That's right.
So I'm going to go to section 2330 right now.
Okay.
I'm entering like a student. So the first thing I'll do is I'll go to announcements,
Okay.
and then where it says extra credit assignment based on chapter 8. So I click on that,
Okay.
and then I'm going to go all the way to the bottom. Do you see where it says chapter 8 extra credit activity?
Yes. Yes.
Click on that. Click on that file. And there it is at the bottom. Now it's in your computer. And now you can open it with Word.
It's still not allowing me access.
So you don't see this document download on the bottom left?
I keep clicking the link and it keeps telling me the same thing. The
Are
access
you
is
using
denied.
Firefox or are you using Chrome?
Google Chrome.
And at the bottom, there's nothing.
Yes, it's not letting me download it.
So it's
It
not
actually it does the same for me too. It says access denied.
okay. So let me look under files.
Actually, I faced the same problem last week, but then I tried on like to check on the announcement and also the email. Like I got like one of them worked though. So yeah, you guys should try like different ways to try to open it, I
Okay,
guess.
let me see upload. That's good that we're getting these questions answered. We have time to do it. And we're gonna go into downloads.
Hey, Alan, what if you just drop the document into the chat right now? Everybody would have it.
Yeah, I'll do that right after I pull it from downloads as well, because I'll do it for you guys, but I have to be able to do it for everybody. So
Yeah, I didn't have the problem. Mine opened from the first time, but I was just saying for like
yeah,
people.
no, for sure. I'm gonna drop it right now. So Sam,
Yes.
can you try it one more time? Can you refresh your connection?
My Canvas
Good.
page.
So go to assignments and then hit refresh. Sorry, go to announcements and click on refresh.
Okay. Did that.
And then go to extra credit
I'm there.
and then go all the way to the bottom and click on extra credit. Is it opening it?
I'm working on it. Hang on.
It's not telling you that you access denied, right?
Yes, it is still. It is still telling me that.
Okay. So I'm gonna drop it. For now, I'm just gonna drop it here onto the conversation. Okay, so file, downloads. And chapter 8 extra credit. So do you see it now in our chat, Sam?
Yes.
Cool. Hopefully that one should upload. Meantime, I'm gonna try to just do a little bit before I move on to question 11.3.
Thank you.
I'm sorry that it's taken so long to gain access to it. It's frustrating to have to.
I've been wanting to tell you that. I really did.
Apologize. I know you guys have been very diligent. I'm very impressed with how you guys have stuck on with all this stuff.
Would it be okay to like resubmit it, because I didn't do the last one because
Sure.
I just
Why don't you send me the last part
Okay.
and say, hey, can you attach this to my other document, and I'll go through the effort on my end, because you've already gone through a lot of effort on your end.
Thank you.
Hey Alan, it still hasn't showed up for me in the chat.
Same.
So I got the questions on
who
the
was
document
that?
itself, but
Carly.
Carly, it didn't show in the chat for you?
No.
In
And
the chat
Panise.
screen? Panise, did it show for you in the?
No, I can't see it.
Okay, let me see.
Hey Alan, so
Yeah.
I did the extra credit assignment, but I didn't I just did off the questions on the announcement and turned in a separate document like that.
That's totally fine as well.
So
If it's in my inbox, it's good to go. And if you sent it, it's there.
can I resubmit it just in case I try it again?
Yes, absolutely.
because I don't know if
For
I did
sure.
it right or anything.
No, not a problem.
I
I
had
have a
another
question.
question. What email should we email you if we have like any other
Lacayo at dvc.edu.
the one on our
The one on, yeah.
the course?
So send me extra credit to alacayo at dvc.edu. And Carly, I'm going to try to see if I can private message you the file, okay?
All right, thank you.
Would that email also be for any other question concerning the class?
True.
Alan, I got the document and the questions, but how are we supposed to answer the questions?
Watch the video and the announcement. That should not be blocked.
The video, yes, that's number B. And like, that's A and B, right? Yes, okay. Thank you.
I have a question about one of the extra credit questions.
Yes.
I watched the video and looked at the transcript, and I even Googled the Med Archive portal
The
and looked.
MedRex VI.
Yeah. So I scoured the internet and everything, but I couldn't find the answers to some. I think there was like 2 of the questions. Like for example, the question 4, I found the part A, exposed to the virus, that was in the video, but I
Mhm.
didn't see any material relating to B, C, D, or E, or F.
I had that same problem.
Try to find a good source for you to finish looking through that. So sorry it's taking me a while. Let me show you what I'm up to so that you guys can also see what I'm up to. Here we go. So COVID-19 data.org.
You think that's a source for our questions?
Yeah, so it's called so this is a good website. So it's called healthdata.org, COVID-19. That may be a place where you can find some of the Carly, did you see the file the next time I sent it or not?
I still haven't gotten it in the chat, no. Oh, wait. No, I just got the health data one, but not the actual file for the extra credit.
Same.
I believe it's supposed to say ch8_extra credit activity 2 in parentheses.
Yeah, that doesn't show up for me.
No worries.
Um,
I'm gonna copy.
Have you
I'm gonna copy the file to you directly by email as an attachment.
Okay, thank you.
Anybody else need that done?
Yeah, can you send it to me too, please?
Sure, I'll do that in a few minutes.
Perfect. Thanks.
So that's one of the data sets. The other one,
Is that like another resource for answers?
Yeah, I'm gonna send you the. So you watched this MedRex IV one that I sent?
Is that the same video?
It's not. It's let me send you that one. It's on. It's what the video was based on. Did you see this?
I was that the link above the video?
This could be just in case this is a different link. There it goes.
I got it too.
And then this is for Panis and for Carly. There's the extra credit question set in text form. Did you see it, Carly, just now?
Yeah, I got that. Thank you.
Okay. So you guys also have this, but I think I can remember to. Good. Pretty sure I can remember to email an attached file too.
Those are just the same questions that are under the video, correct?
Correct.
Okay, perfect. You don't need to email it to me. I have all of those.
Okay, cool.
Thank
And
you.
they're basically now what you could do is take that chat and paste it into a Google Doc or an MS Word doc and
Or Notepad document.
anything, and then just respond to the questions there.
All right, thank you.
My pleasure.
Yeah, this is just the transcript of what was said in the video, right?
Right, but do you see where it says download PDF here?
Yeah.
That's the whole 20-page article. And it's got some graphics that you might find useful. I think the first link I sent you is perhaps more useful than this or the PDF. The data set on another good Google search would be COVID-19 Santa Clara County data or update. So, and then because that's so it's called sccgov.org COVID-19, and that's got the groundwork information from each county. Each county has one of those. So okay. That was a nice recess from the monotony of doing problems. So let me continue with lab 11.
Yes, let's get back to the lab and
question 3 now. Okay. So in question 3, what they're asking is for a t-distribution critical value for these two situations. Okay, so first of all, what is a critical value? So let's go into the background of what a critical value is. Critical value is a z-score or a t-score. A critical value is a location in the sampling model that tells you how many standard deviations from the center, from the middle, you have to create a cutoff point in order to contain a certain level of confidence about an interval estimate. So for example, in a normal world, in a normal model, you'd have a z-score. The normal would look like a bell-shaped distribution. And we know that the bell-shaped distribution obeys so-called 68, 95, 99.7 rule. So if I want to be 95% confident, if I wanted to be 95% confident, then I'd want this area to be 95% of the whole model. That means that this number here is a 2, and this number here is a -2. To be more precise, the calculator would be 1.96. And this would be minus 1.96 deviations. Okay, so that's what a critical value is. A critical value is a cutoff point. It's -2 and +2 in the case of a 95% confidence interval. So if you were asked what is Z star for 95% confidence, the answer is 1.96, plus or minus 1.96. If you were asked about the critical value for 90% confidence, that would be 1.645. If you wanted to know what the critical values are for 99% confidence, then that would mean carving an even greater area in red than 95%. So that would be 2.576. If you wanted to do a critical value for 98% confidence, then you'd have to go 2.328 deviations to the right and to the left of center, and so on and so forth. Okay, so that's, we learned how to do that in chapters 9 and 10 when we were doing, when we did this for proportions. Now in chapter 11, we learn about the t-distribution So to figure out critical values of a T model, we need to know number of degrees of freedom of the model. And the number of degrees of freedom in chapter 11 is 1 less than the sample size, always, or means. And we need to set the calculator to between mode. And finally, we set the area equals to the confidence percentage. Okay, so let me go do that. I'll leave this here for a minute so you can take a picture of that. Let's go to the problem at question here. The problem in question is about finding the 90% confidence with 17 degrees of freedom. And in this case, it's from a T model. So the first thing I do is I go to StatCrunch. I go Stat Calculators T. I set the calculator to between mode. I set the degrees of freedom to the right level. And I set the confidence to the right level. And then I hit compute. And I get the two cutoff points at 1.7396 positive and negative. So that's how many standard deviations creates a 90% level of confidence when you have 18 data points. You have to go 1.7396 deviations, 1.74 deviations. So I go back to the question. And then I do the same for a 2 degree of freedom, 95% confidence. That's 4.3 deviations. So notice how it is not unusual when you have very little data to have to go more than 3 standard errors. You could go 4 standard errors in situations where your amount of data is very little. Your statistics are going to have a lot of error. Less data, more error. Any questions about problem 3?
Alan, how'd you do A again? Because I'm getting it wrong. I must have skipped a step.
No worries, Lance. Can you give me your numbers for 3 for part A?
Yeah, for part A, it's 95% confidence with the difference of 21.
Degrees of freedom of 21. Yeah. And 95% confidence. So you put DF21, 0.95 between mode, and you compute, and it's 2.08. So you have to go 2.08 deviations each way.
Okay. That's
Did
all.
that work?
I figured it out. Yep.
Awesome. So now I'm moving on to problem 4. And in problem 4, I actually have the raw data. And I'm given the following information. I'm told that I need to build an 80% confidence interval for the average of all purchases when I only know what happened to a random sample of 20 purchases with an average of 49.35 and a standard deviation of 20. So when I build a confidence interval, I basically want a low and I want a high estimate. The low estimate is going to start from the 49.35, and I'm going to be subtracting a margin of error here. And the high estimate is going to start from 49.35, and I'm going to be adding a margin of error there. So a confidence interval in the context of chapter 11 is very similar to the one in chapter 9. You're subtracting and adding a margin of error around the initial estimate. And in this case, the margin of error is going to be a compound of a critical value, which measures the number of standard errors. Number of standard errors. And the reason I'm using the t-distribution is because I don't know the population deviation in part A. In part A, I only know the standard deviation of the sample, this 2001. Okay, so this margin of error is basically the product of those two parts, the critical value and the 2001, divided by the sample size square rooted. The sample size is also 20. And the t-score is whatever it is, whatever the calculator says it is. Now, instead of having to do the math for this and then subtract this product and add the product from the original, from the initial, instead of doing all this stuff, I'm going to go to stat, t-stat, one sample with data or with summary, either way. I know the summary information from here, from the second sentence in the first part of in the introductory with summary. Then I move, when I see the data entries, I put 49.35 for the mean. I use the standard deviation of 2001. And I use the sample size of 20. And then I plug in for perform confidence interval. And I set the level to 80%. So I set the level to 0.8. Okay, so you can take a picture of that if you want it, just to get what you do in StatCrunch. And when you click on compute, you get both the low and high. Okay, so I'm going to do that right now. I'm going to go there. I'm going to go to StatCrunch. And I'm going to click on Stat, T-Statistics, one sample with summary. The sample mean and the sample standard deviation and the sample size are entered, and then under perform, move the dot to confidence interval and set the confidence interval to 80%. So once you have that done, just click on compute. Okay, and what you're gonna get is the lower limit and the upper limit. The $43.41 and the $55.29. So that's what you get when you do stat t-stats, one sample with summary. So if you want to take a photo of that stat crunch or capture a screen of that stat crunch, that's a useful screen because the command structure is right here in the middle. The window that you open is on the left side here with the appropriate data entries and confidence interval entries. And then when you click on compute, the answers are down there. So that's how you would do a confidence interval for a situation involving a t distribution. Okay, so I'm going to go now back to the question. And in the question, the answers are 43 with 41. And then the upper value is 55.29. So notice that the lower limit is below the average that you started with, the $49 average, and the second number is above by a certain amount. So the answer is right. Then it asks you for what is the margin of error. And the margin of error is the distance from the upper limit to the middle. It's also the distance from the middle to the lower limit. It's also the upper minus the lower divided by 2. So whatever you prefer to do to calculate it is fine. Okay, so in this case, the middle is 49.35. And the lower limit is 43.41. So this is a little under $6 worth of a difference. It's $6.94. So that's what the margin of error is. Ah. $5.29, $5.89. Sorry, it's $5.94. Again, the margin of error is just the difference between either of the limits and the middle. So 55.29 to 49.35 is almost $6. So that's how you calculate the margin of error. And then for part C, where it says, how could the confidence interval change if you know the population standard deviation? In this case, the population deviation is known to be 21. So what we're going to do to calculate this new narrower interval. Now, why would it be narrower? It's narrower because in part C, I know something about the population. So I'm using a different model. I'm using the normal model, not the T model. So rather than go stat, T-stat, one sample with summary, and doing what we did on part A, we're going to do stat Z-stats, one sample with summary, Z-stats. The sample mean is not going to be any different. The standard deviation is 21, and the sample size is 20. So this is the big change right there. The big change is that we don't use the sample deviation. We don't use 2001. We use the 21 that we were given. Okay, and we end up with 4333 to 5538, which is a little wider, actually. Because the real deviation is 21, not 20. So it's a much larger deviation. It's 5% more deviation each time. So in this case, it ended up being a wider interval than before. But in yours, it could be that the interval is narrower because you have a normal model. So the z-score is smaller than the t-score.
I'm sorry, where did you get the 21 for the standard deviation?
From the question. I'm highlighting the question. Let me put it on for you. Sorry, I didn't have the question up. So in part A, when they ask you to build a confidence interval, you use all of the sample data. But in part C, you're to use the given population deviation. So that's where I got the 21 from.
Okay, I'm sorry, I found it. Thank you.
So in your case, it's going to be a little different. It could be a different number, but it's embedded as part of the question in that case. Okay, so that was question 4. Carmen, we're reaching question 5 now. And then we're going to turn to question 7 after that.
Sure. I only have questions about D because I figured out one like ABC already.
So in this case, I want to know if my customers average 25 years of age. So that's my question. Are my customers on average 25? So I would say the average age of my customer is, because in hypothesis testing, the null is always the equal sign. The alternative hypothesis is that my customers are not 25 on average. So it's what we call a two-sided model. I have data where 25 customers were sampled randomly. The average age of those 25 people is 29, almost 30 years of age, give or take 12 years of age. So I'm going to calculate the test statistic by using stat, t-stat, one sample, again with summary. And I'm going to set the mean to 29.8, the standard deviation to 12.37, sample size to 25. I'm going to set a confidence interval. Sorry, I'm going to leave this as a hypothesis test. The null is going to be set to the age of 25. The alternative is going to be not equal to. And then I'm going to click on compute. And I'm going to get the test statistic and the p-value. So that would be the sequence that you would use in a situation like this. I'm going to go through that in StatCrunch, and then we can get back to this. So I'm going to click on hypothesis test. The average age is 25 versus not equals. My sample had an average of 29.8 and a deviation of 12.37. And I have a sample of size 25. So I put the data in, I leave the perform button under hypothesis test, and I get computation. That gives me a test statistic of 194 and a p-value of 6%. So this is 194. The p-value is 0.062. My level of doubt in testing this hypothesis is 1%. Since my p-value is greater, I reject the null. I don't reject the null. I don't reject the null because I have more faith in the null than I have doubt in the null. So I find this not enough evidence to say that my customers do not average 25.
Alan, can you put the question back on the screen? It's on StatCrunch.
Oops, sorry.
Thank you.
You guys are super nice to me. You should say, yo, put it back, man. Get back to the problem. I apologize. You guys are too nice, man.
What's what students are for, right? Showing respect.
I don't know, man. Oh,
Hey, Alan, on C for the test statistic, that's the part out of the summary that's T-stat, right?
yeah, let me go back there for a moment. That 1.94 is when you're comparing.
Okay.
Alan, can you tell me one more?
It's when you're comparing this, the 29.8 you see, to the 25 that you hypothesize. So when you compare how different what you see is from your hypothesis, that's a 4-year difference, almost a 5-year difference. And that 5-year difference is almost 2 deviations apart.
Got it. Okay.
So there's almost a 2 deviation difference. And the chance that you see that in a statistical problem of this kind is you could see this with a probability of 6.5% of the time, that population that averages 25 years of age, you pick out 25 people and your average from those 25 people is almost 30. There's a 6% chance that that could happen. And that sounds like a low probability, but it's better than the 1% chance that you're allowing yourself to be rejecting the null hypothesis. And for that reason, you fail to reject and you have an insufficient evidence to say that the null is contradicted by the data. So in this case, the null is different, but not different enough to contradict the hypothesis.
Hey, Alan. So for D for the p-value, when I put in my stuff just the same right way and everything, so I got the z-stat and it's right, and then the p.
It's not a z-stat, it's a t-stat.
Oh, maybe that's why. Okay, that might be why. Thank you.
That's absolutely what's going on. So let me show you the difference between a t-stat and a z-stat. Okay, so here we go. I'm gonna move to StatCrunch for a moment. And I'm gonna do 2 calculations. I'm gonna do a calculator that's normal. And I'm gonna do another calculator that's T. So what you did was initially a z-stat, and you put here 1.94 and minus 1.94. And so you ended up getting this area here that's almost 95%. So what's in the white parts? In the white parts, you have 0.0524, which must be the p-value you were getting if it were normal. But in a world with 24 degrees freedom, where you start from 1.94 deviations right and left, you only capture 0.9358. So here the p-value is 0.0642. And that's the p-value if it's a t-distribution. So there, you can see the difference that these tails have more area. These white parts here have 6% opening. The normal case only has 5% opening. So that's the difference between a normal situation. This is if you knew the population standard deviation. This is when you don't know the population standard deviation. In other words, this is stat z stat here, and this is stat t stat. Does that make sense visually, what you're calculating as a p-value?
Yes, thank you.
Yeah, it's what are the odds that what you're seeing could have come from a world where the null is true? That's what a p-value measures. The chances that your null hypothesis are okay. And so those chances vary according to which model you have. And the models are a function of what you know and what you don't know. And then so are the probabilities of the data confirming the null or rejecting the null. Okay. So be careful with when you use t-stat and when you use z-stat. You use z-stat when you know the population deviation, but if you know only the sample deviation, then you use t-stat.
Hey, Alan, real quick on the E. So my numbers are different than yours, obviously, but I was pretty much the opposite of what you were, because it said mine was 0.10, and then so my p-value is like 0.03, so it's less than.
So you
And-
reject the null and you
Yeah.
have sufficient evidence.
So why do you reject it? Because it's less, right?
You reject it because your level of doubt is 10% and your level of confirmation is 3%. So the chances that you're doing the best thing by rejecting are higher. 10% beats out 3%.
Okay, so if it was if my p-value was like 9%, I would
You
still
reject.
I would still reject. Okay. Okay.
Your p-value has to be bigger than 10%.
Got it. Okay. That cleared it up for me. Thank you.
Cool. So that's how all hypothesis testing always works. There's just two probabilities, one in favor of the null, the p-value, and one against the null, which is alpha. If alpha is bigger, reject the null. If p-value is bigger, keep the null. If it's a tie, keep the null. Okay, so if you have a confidence interval and the standard deviation increases, you're going to have a more width. Because more deviation means more error, and more error means wider interval. Okay. So again, what is a margin of error? Now we're in problem 7. I think that's one of the last questions from Sam.
Then I decided to bring up exam questions when that's done. And as did the airman.
So notice what's happening here in part A. You have an interval that's built based on 25 car speeds. And the interval goes from 8.4 to 13.2 miles an hour. What's that? That's a difference of 4.8 from beginning to end, from low to high. So what is the margin of error? The margin of error is half that much. Because in a confidence interval, you go a margin of error to the right and another margin of error to the left. So an interval is 2 margins of error wide. So the initial margin of error is 2.4. .4 miles an hour. Now you're going to now what you want in part B is for your sample size to be reduced to a margin of error of 1. And the only thing that's changing is that instead of the margin of error being 2.4, you want it to be 1. So you want the error to be 2.4 times smaller than before. Okay. So what is the square root of 2.4? Somebody do the math for that? I'll do it with my phone. So I'm going to take the square root of 2.4, and it's 1.55. So I need 1.55 times more data if I want to have 2.4 times less error. I want my error to be smaller, so I want my data to be bigger than before. Sorry, it's not the square root of 2.4, it's 2.4 squared. So that's almost 6 times more data. So it's 2.4 squared. That's 5.76 times more data. What was my original amount of data? My original amount of data was 25 speeds. So I need to multiply this
By 25.
and that gives me 144 observations.
Yes, that's also 12 squared.
Didn't like me. Says that's wrong. So instead of doing that, let's use the equation for sample size. So what is the equation for sample size? Well, we know the margin of error equation is a number of standard deviations. So if I know that I want 90% confidence, I know the standard deviation of the model, that's this 7 here. And I know that I want this to be 1. So the sample size is going to be 1.645 times 7, all of that squared.
Where did you get the 7? Is that the standard deviation?
This came from my standard deviation, which is
Okay, yeah, perfect. Just checking.
and I get 103. 104. Because this is just a 1. So anything times 1 is 1. And then since the n is inside a square root, I have to square everything to get rid of that square root. So I need a sample size of 104. Sorry, my math was wrong in the earlier calculation. So the way I got this 134 is, let me show you the board work. So this is problem
7.
7 out of 8. Okay. So this is lab 11, question 7. And we know that in a confidence interval, where the population standard deviation is not known, the margin of error is t-score times the standard deviation of the sample divided by the square root of the sample size. And in a confidence interval where the population standard deviation is known, margin of error is a z-score times the population standard deviation over the square root of the sample size. So when you're looking for a sample size, you basically have to flip that equation above. You flip this equation above. And what you need to know is you need to know the confidence level. And that's because that's what's going to give you the z-score, the critical value of z-score. You need to know sigma, and you need to know E. So in this case, E is just 1. In my case, sigma was just 7. And the z-score was 1.645. And we learned how to calculate critical values to start the session today. And the formula here is going to be a ratio. It's going to be a ratio of the z-score squared and the sigma squared. And here I'm going to divide this by the margin of error squared. So in my case, this is equal to 1.65 to the power of 2 times 7 to the power of 2. And that was 134. Because the margin of error was 1, so 1 squared is 1, and dividing by 1 is 1. And the important part here is the formula. Okay. Are you guys okay so far?
Yes, thanks.
Let me inspect number 8. I think that's the last one. What does a 1% p-value mean? It means that there's a 1% chance that the average from a sample confirms the null hypothesis. In this case, the null hypothesis is that the average amount of monthly sales don't change or stay the same. So when you have a 1% p-value, it means that there's a 1% chance that your monthly sales have not changed. So a p-value is a probability. It's a probability that the data is just confirming the null hypothesis. The null hypothesis is always a hypothesis about the mean being equals to something, to some numeric value. So if the mean is going to remain the same, be equal from one month to another, then that's what it means here. To say that sales from month to month do not change, they remain equal. And there's a 1% chance that the sales we just observe in a month are consistent with that. Let me look at quiz 11.
I have a quick question.
Yeah.
So if on Pearson, if it says you have above 1,000 points, that means we have an A in the class, correct?
You already do, correct.
All right, perfect. Thank you.
That's what it means.
Also, so does
But Pearson, let's say that I go to my gradebook right now. So I'll go main menu, gradebook. Okay. So do not look at these points. Those are not right.
The 222 points are all extra.
What's right is you go to where it says past 2 weeks to the entire course to date, and you add every single lab points, every single exam point, and only the higher quiz score. Well, by that I mean when you take the quizzes more than once, if you got 2 or 3 grades for each chapter quiz, only pick the highest of the grades per chapter. At the end, you're going to end up with 11 chapter quizzes, 11 chapter labs, and 5 exam grades. 1, 2A, 2B, 3, and 4. If you did 5, that's all extra credit. If you did chapter 8 extra credit, that's all extra credit. So you take all those points, not the percentages, just the points, and add them all up. If that adds up to more than 1,000, you have an A. If it adds up to more than 850, you have a B. Okay, so these 222 points that you see over 1,000 there are the points that we had in excess of 18 that were called the extra credit points in each activity in the class.
Which ones are extra credit, you said?
There's no designated question that is extra credit. It's the total point scheme that tells you that there is extra credit in that activity. Every lab is worth 18 points. Every quiz is worth 18 points. Every exam is worth 150. Anything above that is extra credit in that activity.
You said like there were 5 exams, and but then you didn't count exam 5. So is there 6 exams?
I said that anything you earn in chapter 12, anything you earn in chapter 14, in lab 12 or quiz 12, anything you earn beyond exam 4 is extra credit. And that includes the chapter 8 extra credit. And that includes exam 5 and chapter 14 lab and quiz.
Oh, okay. Okay, thank you.
Wait, can you explain one more time how to calculate that?
Sure.
Sorry.
That's okay.
I'm with you. Yeah, I need that one more time too. Thank you.
Okay. So go to gradebook. You got that?
Yes.
Then go to, then ignore the top
Okay.
and go to where it says past 2 weeks and change it to entire course to date.
Okay.
And then you'll see a bunch of activities, about 30 activities.
Mm-hmm.
Add up everything that says lab to everything that says exam. Now, in some of the exams, you took the exam over more than once. The score that you'll see is the higher score selected. On the other hand, in the quizzes, when you take the quiz more than once, you see every quiz score. So that's where you have to filter out only the highest quiz scores. Let's say that I have 2 chapter 5 quiz scores, one for 10 points and one for 30. I don't count the 10, I only count the 30.
Okay.
So after you count all your quizzes plus all your labs, plus all your exam points, plus all the extra points that you may earn in the chapter 8 extra credit and the exam 5 module, that's your point total. And then you just apply the grading policy in your syllabus. And in your syllabus, the grading policy is very clear. To get an A, you got to make more than 1,000 points. To get a B, you got to make more than 850. To get a C, you got to make more than 700.
Thank you. That cleared it up a lot for me.
All right, thanks.
Now, quiz 7. My camera was fine. Excellent. Okay. So when we go to quiz 11, let me see if it's worthwhile working through it. I think quiz 11 is very much, okay, so what is the one-sided critical t-score, 2.5% alpha, 19?
It's not showing the quiz.
So to do this first problem, you're looking for a critical t-score, where on one side of the distribution you leave out 2.5%. So that means that the middle area is 95%. So just open the normal calculator and do what we did in the lab to find a t critical value. In second question, you're doing a hypothesis test to see if the true average is less than 4 ounces. So that has to be B. Because nulls always have equal signs, alternatives never do. So a less than 4 is your alternative hypothesis. At the 5% level of significance, you're doing the test of hypothesis for this data. So you just plug it into stat, t-stat, one sample with summary, and you're comparing 3.8 to 4 in standard deviation units. Then you're testing this at a significance level of 5%. So the first 4 or 5 questions are the same hypothesis test. And then you're asked a question about travel and being on-time departures in planes, where there's almost no correlation between the data points from one month or another. So you should be able to see if the data are random, independent, and less than 10% condition is met, and the nearly normal condition is the characteristic in data that is quantitative, that it should be roughly symmetric in shape. And then the way you find this confidence interval is by doing stat, t-stat, one sample with summary and entering this information in the summary. And the same is true of question 6. It's just another question like 5. Stat, t-stat, one sample with summary. Question 7 is another stat, t-stat, one sample with summary. So you find the low and the high confidence interval. Question 8 is, you can do question 8 by loading the data and do stat, t-stats, one sample with data. Then this question is again a stat, t-stat, one sample with summary. And this is also a stat, t-stat, one sample with summary. Random, independent, 10%, nearly normal. And then proceed, the 4 conditions that make this a t-distribution model. So quiz 11 is very similar to lab 11. I don't want to work through it all to leave you guys with something to do in the week and ask questions about, making sure that you're getting it done right. And then with respect to exam 4, I've covered in previous chapters the first 7 questions of exam 4, the questions from chapters 9 and 10. I'll go through some questions before we leave today, but then the last 3 questions of the exam questions 9, 8, and 7 are all questions about the average the confidence interval for the average cost of an audit. So this is just like one of the quiz problems I just reviewed. Stat T stat, one sample with summary, blah, blah, blah.
It's not showing the quiz again, Alan.
Oh, that's my fault. My bad. So question 9 is a question where you have a starting amount of a cost of an audit, and you just have to find how much to take away, and then you have to find how much you add. And you do that with stat T stat, one sample with summary. And you see if the old average is inside this range or outside of this range. Then this doesn't look like a normal shape for the data.
It's skewed. It's obviously skewed.
Yeah. So you should be cautious making inferences because it does not appear that the data set is normal, approximately normal. It's skewed to the left. And there doesn't seem to be outliers, but it's not normal in shape. So you should be cautious making inferences from situations when the data don't obey the 4 conditions of data sets and means, which is you should have a random sample. The observation should be independent. You should have less than 10% of the population of data. And the shape of the data sample should be roughly symmetric. Any of those 4 conditions are missing, the model T and the model Z are not going to give you exactly good results. And like here, you're testing if the average age of customers is 32.
32.
Based on the problem here, versus not 32. And then the test statistic and the p-value come from, so this is just like the lab question we just did. Lab 11, lab.
To find the test statistic and p-value, what are you to do?
Stat t-stat, one sample with summary. And then you run a hypothesis test. And then question 6 again, this condition, the normal condition is not satisfied, even though in my case, these 3 conditions may not be satisfied. Because it says here that the histogram shows the amounts of a sample of 20 consecutive purchases.
If a histogram is almost symmetrical, like going down and then up again,
then the nearly condition is satisfied, but in my case, it's not. And in my case, my data samples are not random because I took 20 purchases at a large store. And the fact that they were consecutive purchases means they're not random because they're one after the other. Okay. And then we've done hypothesis testing in chapter 10 of proportions. We've done problems exactly like this one about the drop rate of a class falling. We have that in our notes for chapter 10. Okay, same here. Sample size questions. We've done that in the notes for chapter 9. Confidence intervals. And proportions, chapter 9. You should have, I hope, an easy time going through the 2 iterations of exam 4. Based on
Alan,
the lab
Alan.
analysis that we've done
You didn't do number 9, did you?
on.
Exam 4.
I didn't. I just reviewed it a little bit. I didn't do it. No. We still have a week, so I want you guys to think about it a little bit more before you have 2 tries. But
I'm on my second try
question
right now.
9. So if you're in question 9, that's a chapter 11 question. So all you have to do is build a confidence interval using the summary data given to you in the question. And there you use stat, t-stat, one sample with summary, and you're building a confidence interval of 95% confidence. So it's just like what we just did in the lab 11, except that the mean is 650, the standard deviation is 75, and the sample size is 37. So it's just a matter of opening StatCrunch and
Sample size, did you say?
going into stat, t-stats, one sample with summary. And then plugging in the sample size, the sample mean, and the sample standard deviation, and doing a 95% confidence interval, and getting the 2 results, and you're done. So once you
Could
have
you
the
go over?
results, I'm sorry?
Could you go over exam 3, question 5, and question 10?
Sure. Exam 3.
Let me pull it up too. Okay, I have it right here.
I don't know if your question 5 and mine are the same. So let me see if context may matter. So let's do that. Let's pay attention to context a little bit here.
Okay, mine is about Mary is deciding whether to book the cheaper flight from home from college after her final exams.
Cool. So Mary has 2 choices. So let me put the 2 choices in in some columns of StatCrunch. So here are Mary's choices. One is to book cheap. The other one is to reissue. Because if she can leave before a certain date, she can use the ticket that she booked for cheap. And in that case, she saves $50. If she has to buy a reissue of a ticket, she's gonna lose $100. And the probabilities of these 2 values are depending on whether she can take the exam before the cheap flight or not. And there's a 90% chance of this and a 10% chance of that in my problem. So let me go back to my problem so we could see that table. Mary is deciding whether to book a cheaper flight. She thinks there's a 10% chance that the final occurs after the cheap flight leaves. So there's a 10% chance that she could lose $100, which means there's a 90% chance that she can save 50. So here are the 2 possibilities as what we would call a custom model. So then we would go to Stat Calculators Custom, where the values are in the column with the monetary values, and the weights are in the probability column. And when you click on compute, you get that the average for this is a $35 value with a standard deviation of 45. So in the exam, the expected gain is $35 with a give or take of $45.
Okay, so it's best to use StatCrunch to solve that problem.
Well, if not, you have to do the math for the expected value.
Yeah, that's what I did. And
Yeah.
I guess obviously my numbers are different than yours. Mine is a
Well,
30% chance, and she'll lose 300, and she will save 200. And I got $50 for the first one, and I'm confident about that one. But the second one, I calculated the standard deviation using mathematical. I didn't use StatCrunch, just through
so
math.
here what you do is you first need to know the average. So the
Yeah.
average here is negative 90 plus 140, which equals 50.
Yeah.
And then over here, you need to do 0.3, and it's minus 300 minus 50 squared, and then plus 0.7 times 200 minus 50, all of it squared.
Yeah, I got that.
And then you gotta take all this and square root it. In
Oh,
order to
wait.
get it to a standard deviation. Because if you don't square root it, you have the variance.
The exponent is 0.5.
Well, that's the same thing as square rooting the whole thing. That's the same thing as taking.
Oh yeah, square root. Okay.
That's
Oh,
the same
okay,
thing
yeah.
as taking this whole mess and putting it under a square root sign like that.
Yeah, well, the problem I ran into was under the square root, I had a negative number.
Yeah, it's impossible.
Impossible?
Impossible, yeah. Because you see
Okay,
how
let me
this is minus 350, right?
yeah.
Okay, so minus 350 squared turns into a positive. So this negative sign is moot. And this
Minus
turns into
350.
150 and 150.
Oh, I see. Okay, so yeah,
So
where
the
I went
negative
wrong.
and the negative go away because of the squaring.
Yeah. See, I inputted that into my calculator. I don't know what happened.
It happens.
Okay, so
Which is why I prefer that you do the following. So we're
yeah.
going to do a minus 300 here, 0.3, and a 200, 0.7. And then I'm going to just recompute. So the standard deviation is 229 with a 13.
Okay. So yeah, so
Okay.
just set up the table on StatCrunch and then compute it.
Yeah, or just take this number since you have it right there. 229.13 is my take on your
Okay.
question 5. And then what other question did you have?
Question 10. Let me go to it. It might be different. So it's at a certain coffee shop. They're talking about buying coffee and donuts.
Mm-hmm.
340 cups.
3 different models.
Yeah, 3 different A, B, and C.
This one here?
I can't see it. It's not showing the question.
Okay.
Yeah. Yeah, that's
So
it.
here the model is called a compound model because it's 6 days of coffee sales.
Yeah.
In part B, the model is about how much money you make in coffee sales and in donut sales. So how much money you make overall.
Yeah. I think
it's a
we're
different model.
Uh-huh.
And in C, the model is you'll sell a donut to more than half of the coffee customers. So your donut sales, if I take away half of the coffee sales, will have a value that still is greater than 0.
Okay,
So
I got stuck on A. and I got all the way down. I mean, through question help, I calculated. I got all the way down through the steps except for the last step, and I got to the standard deviation. I got the variance, and I got the standard deviation. But the last step, it says use technology to find the probability that more than 2,000 cups of coffee are sold in a week. So using technology, I don't know how to use the technology to find that last step.
Got it. Okay. So I put in a PowerPoint slideshow in your course tools document sharing. So let me go there first, and then I'll show you what you can do in this kind of a problem. So first, let's put your data here. So you have items.
Oh, I'm not seeing it on the screen.
Okay, so you have items for sale. You have coffee. And you have donuts. The expectation is that you sell how many coffees a day?
340.
And what's the standard deviation?
Standard deviation is 21 cups.
And for donuts?
Donuts, a mean of 140.
And a deviation of?
Standard deviation of 12.
Okay. And then you have some prices, some profit margins. Your coffee profit margin should be 50 cents and your donut 40 cents. Correct?
Yeah.
Okay. And we have 3 different models that we're making with coffees and donuts. So I'm going to do the following. I'm going to go to data, and I'm going to compute 6 expressions. The 6 expressions are for part A, the mean, part A, and the standard deviation for part A, then the mean for part B, and the standard deviation for part B, and the mean for part C, and the standard deviation for part C. So the mean for part A is easy. It's just you work 6 weeks a day, 6 days a week, because you take Sundays off. So every day you work, you average 340 cups of coffee. So that's your mean. And then your standard deviation is the square root of the variance. And the variance is 6 times 21 squared.
Yeah.
Because every day the variance is 21 squared. So
Yeah.
that's how you do the mean and the deviation. Then for part B, the model for part B is a model where you're making money, and you're making 50 cents per cup of coffee. Plus, you're making 40 cents for every donut. And here, the standard deviation is the square root of the variance. And the variance is that you make 50 cents for every coffee plus 40 cents for every donut. After you add the 2 variances together, you then take the square root of the whole thing, and that's the standard deviation. And then for the third part, you sell more. The question is, can you sell donuts to more than half of the coffee customers? So you would take the donut expectation and subtract from it 1/2 of the coffee expectation. And in the standard deviation, you take the square root of the variance. And the variance would be the variance of the donuts and the variance of half of the coffee sales. Add it together. So those are the formulas. I'll leave them there for a second for you to take a picture of those. So I did those calculations for mean and standard deviation, compounding coffee and donut either profits or units in the according to models A, B, and C.
Okay.
Okay, so there are my three means and my 3 deviations. So for part A, all I have to do is do the calculator with a normal model where the mean is mean of part A. So instead of putting anything here numeric, I can say mean underscore part A. And here I can do the same as the part A. And then I want to know what the chances are that I sell more than 2,000 cups of coffee or less than 2,000 cups of coffee. I think it's less than, right? For part A?
It is over 2,000 cups of coffee.
Cool. So there's a high probability that I will make over 2,000 cups of coffee in sales.
Okay.
Let me see why that is. $1,800 plus 240 is 2040. Yeah.
Yeah, I got that.
Cool. So that's the answer to part A. Part B is a little bit different.
0.782 is the final answer.
Cool. Yeah.
Right, yeah.
And then for part B, we're just going to change this from A to B in the end here. From A to B. And we want to know what the chances are that we make more than $300 in profit. The standard deviation for part B doesn't look good to me. Let's see. Oh, there it is. This is not to the 21st power. This is to the square. So that had an error, which means this was bad. So I'm going to redo that computation. Data, compute expression. This one. And that one's going to be called SD part B. That's 11.54. That makes a lot more sense. So I had a typo here. I had there this to the power of 21. So that's why it wasn't. This is mean part B. And it's called PRTB. So this has an extra A here. There we go. So the chances that I sell $300 in profit are near zero. And that's because $300 is 1, 2, 3. It's more than 6 deviations away from 300 or more than 7 deviations. So that's just picking that it's impossible to sell more than $300 in profit in a day because that would be like 7 standard deviations or 6 deviations above the average. So I think you got that one right as well, correct?
Yeah.
Cool. And now for
Okay.
part C,
Yeah, because I was doing in my calculator and I got that that weird number E dash a number. And
yeah,
I
what that
wasn't
means
sure.
is that it's nearly zero chance.
Oh, okay.
And there's the chance that you sell donuts to at least half of the coffee purchasers. The
Yeah.
chance that you sell donuts to more than half of the coffee buyers is 0.0299, so it's 0.03.
Okay.
So that would be and the answer is because the mean is minus 30. The deviation for that is 15.95.
Uh-huh.
And so the chance that you sell donuts to more than half the coffee buyers would be 2 deviations different than usual. And that has a 3% chance of happening in this world. So
Okay.
your answer to part C is that it's a 3% chance.
Okay. And then just to be totally clear, part A, you do, so you take the square root of 6 times 21 squared, which is 144, 6 times 144, and then you take the square root of that, and that's the final answer.
And that's the 51.44.
1.44.
Yeah. So the mean is 2040. The standard deviation for part A is 51.44.
Okay. Got it.
Because it's right up here in this box that I just highlighted.
Okay.
That's what the square root of 6 variances is.
Yeah.
And so the chance that you sell more than 2,000 cups of coffee is 0.782.
Okay. Yeah. 0.782.
And in part B, you're just doing a z-score calculation for how far 300 is from 226, which is $74. And $74 in chunks of 11.5 is more than 6 deviations.
Okay.
And so that's why you pick more than 6 deviations on the exam 3.
Okay.
Cool. So we have exam 3, questions 5 and 10. Carmen, are you still interested in quiz 5 or is Carmen gone? No, Carmen's still here, but I think I went
She's
over
muted.
pretty much everything on the list. It took a little bit more than 2 hours, but I'm going to stop recording now. And then as soon as the recording gets processed by Zoom, I'll send the cloud link for you guys to download it.
In chat, I believe I sent you my calculations of total points. I used the grade book and the best attempts on every quiz test.
Excellent,
And
yeah. Thank you so much.
but look,
Oh yeah, congratulations. That's great.
so I must be good to go. But I'll still come back to every Zoom meeting for the rest of the week.
Okay, well.
You've been a great